Hello, Geometry. Today I'm going to talk about examples numbers 9, 10, 11 in your student journal on page 178. In these exercises, they tell you that you're dealing with an orthocenter, which remember is the intersection of three altitudes of a triangle. An orthocenter can land inside, on, or outside the triangle. The orthocenter is a point, so it can be labeled using coordinates, just like we see here. We're going to use the coordinate plane to help us construct a triangle and also find the coordinates of the orthocenter by using equations of lines. We're going to do this using Desmos. And a few things to remember before we go over to Desmos is to remember that an equation of a line can be in the form of y equals mx plus b, which is slope-intercept form, where the value of m represents your slope and the value of b represents your y-intercept. There's a little bit more information here about b. I'm going to talk about that in Desmos, so I'll show you that. We'll see that if we add a positive b, our graph will move up. If we add a negative b, our graph will move down from where it is if b was 0. Another thing that we talked about in class, but I just want to point it out again, is that slopes of perpendicular lines have what's called an opposite reciprocal. An opposite reciprocal, I'll give you a couple examples of that. The other thing we know about lines is that when the lines are perpendicular, the slopes are what we call opposite reciprocal. You may have been told negative reciprocal, same thing. So for example, if my slope of a line was 5, that means that the slope of the perpendicular line would not only be opposite, so in this case negative, but also the reciprocal of that number. So the reciprocal of 5 is 1/5. So if a line has a slope of 5 and a slope of negative 1/5, those two lines would be perpendicular. Another example could be if you have a slope of let's say negative 2/3, the slope of the perpendicular line would be positive, and also the reciprocal, so 3/2. Remember that perpendicular lines, another example, if you don't know what the slope is, maybe they're giving you a horizontal line, that would be an equation in the form of y equals some number, I'll just say 2. If you're going to draw a perpendicular line, it would need to be straight up and down vertical. Those types of lines are written using the form x equals some number, I'll just say negative 3. So a little bit of information there before we go over to Desmos. I'm going to do number 11 in your student journal on page 178 using Desmos. So you're going to go ahead and go to desmos.com. I have that bookmarked at the top. Not a bad idea to do that. You can click here at graphing calculator, or you can use the math tools, and there's a bunch of math tools there that you can use, one of which is this graphing calculator. Okay. All right. So first of all, we need to construct the triangle in our coordinate plane. So I'm going to show you how to do that. They give you points P, Q, and R. So I'm going to insert those using a table, okay? And up here where it says y sub 1, I'm going to change a little bit of settings here. I don't want just points. I want those points to be connected. So kind of click on it and hold it till you get this little menu here. And then you want to slide over with this slider so that you actually get lines, okay? Other things that I like to do with my settings over here in the graph settings, there's lots of settings. I like to get rid of these minor grid lines so I'm not confused. Lots of lines. And I also want my step to go by 1. So that way I see every number. So you can see before it was going by 2s. I want to see every single number. I think it just makes it a little bit easier to deal with. So again, you don't need to make those changes, but I'm going to do that so you can follow along with me. Okay, so go ahead and put our points in. Point P is 3, 4. And then point Q is 11, 4. You can see it's starting to connect it there. And then the third point is 9, -2. Okay. So you'll see that you've only gotten, you only got the lines that go from point P to, so you can click on these to get the actual coordinates there, P, Q, and R. If you want R to connect to Q, you have to enter the first point in again. That's just a trick with Desmos. Another reason why I'm doing this video, in order to get your whole entire triangle. Now, you're not going to be able to label these points with P, Q, and R, but you can definitely click on each vertice, and you can at least see the coordinates, and then look at your student journal to see what letter they're dealing with. All right, let's go ahead and draw some altitudes. Now, remember, an altitude has to go from a vertice to the opposite side, perpendicular, okay? I'm going to start with drawing from 9, -2, which is point R, to the opposite side, because the opposite side is a horizontal line. So I know that the perpendicular line has to be vertical. An equation of vertical lines will always be x equals. If you're not sure what number needs to go after the equal sign, just put a number in and see where it lands. You can see there it's black. If you want to change the color of your altitudes, you absolutely can. I'm going to make mine orange, and I'm also going to make them dashed. Okay, so a couple options there. So then you can see they give you a slider, actually. So you can change the number by hand, or you can just slide it until it hits your vertice. Oh, there it is, right there, at x equals 9. So you can see that this is a vertical line, this is a horizontal line. They are definitely perpendicular. This line goes through the vertex. That is an altitude, okay? You're not going to see a little right angle symbol there, but imagine that it's there. You can't draw that in Desmos, but we know that it's there. Okay, so now we're going to find another equation of a line. Remember that we're doing our equations of a line in the form of y equals mx plus b, okay? Got it? All right. So we're just going to leave that like that. I know it has this little thing there. I can delete that later. You can add sliders if you want to, and you can use the sliders to help you figure out where this graph is going. See, as b is positive, you see the line moves up. As b is negative, the line moves down. So if you want to do it that way, you definitely can, but I'm not going to do it that way. I'm going to show you a different way to do it. So let me get rid of those. Again, the way you get those sliders is you type in y equals mx plus b and just hit all, and it'll give you a slider for both. But actually, here's a good idea. I just thought of this right now. I'm going to change the slope, okay? And I'll do a slider for b, but here's what we're going to do with the slope. Pick one of the sides of the triangles, okay, or a vertice, I should say. It doesn't matter. And think about, so I'm going to pick this vertice here, 3, 4. So I want my altitude to go through this vertice to the opposite side, but I want this line that I'm going to draw to be perpendicular to this side of the triangle, right? Because remember, from the vertice to the opposite side, it should be perpendicular. So I need to construct a line perpendicular to this side. We know that perpendicular lines have opposite reciprocal slopes. So what I'm going to do is I'm going to find the slope of this line using rise over run. So pick 2 points on this line. So that could be this point and this point, right? So we're going from this point. I'm going to go up 1, 2, 3, and then I'm going to go right 1. That gives me a slope of up 3 over 1. It gives me a slope of 3. That means that the slope of the perpendicular line needs to be opposite, so negative, and reciprocal of 3, 1/3. So I know that the slope of my altitude has to be negative 1/3 in order to be perpendicular. So I'm going to go ahead back here and I'm going to put negative 1/3. And we don't see a line yet because we don't have a value of b. So what I can do is I can click this b to add a slider. So this is really cool. And what it will do is if you change the value of b to make it negative, you're going to see it's going to go down. So I'm going the wrong direction. Okay. I want to make sure that this line, which I know is going to be the blue line, I know it's going to be perpendicular to this side of the triangle. I want it to go through this vertice so that from this vertice to its opposite side, it's perpendicular. So I'm just going to move my slider until I get there. Whoops. And there you go. There's your line. And again, if you want to change the color and change it to dotted, you absolutely can. Okay. So you could definitely find the third altitude, but here's what I'm going to tell you. If two of the altitudes intersect at this point right here, there it is, then that means that all three of them are going to intersect there. So you can go ahead and find the third altitude from this vertice to the opposite side. But I'm going to tell you that if two of the altitudes intersect at this point, the third altitude has to also intersect at that point. So you really only need to find two altitudes to find your intersection, which in this case is going to be our orthocenter. So you can see for this triangle here that my orthocenter lands inside the triangle, which makes sense because this definitely looks like an acute triangle. And my orthocenter happens to be 9, 2. So that is going to be your answer for this problem. So there it is. Woohoo! If you need to change the values on the sliders, like if they didn't give you, like it goes from negative 10 to 10, just click on this number and you can change it. Like I want my slider to go from negative 50 to 50 by ones. You could definitely change the slider if you need more numbers. Okay, so I just wanted to mention that. If you need to go away from your work and come back to it, you can save your graph. So I can title this number 11, student journal, page 178 for what section this is, section 6.3, right? That's a really crazy name, but you can name it whatever you need it to be named, and save it. The only way that you can save it is if you're logged into Desmos, which you can log in using Google, just like we have for any Desmos assignment that we may do in class. Okay, and that's my video. And I guess the last thing you would have to do is go back and put your answer. The answer is it would be inside the triangle, and the orthocenter is at 9, 2. So that would be your answer to number 11. And you'll have 2 problems like that in your homework. Please use Desmos to do this. Come to support if you need help, and best of luck with your practice.